An FRQ, doing a Lewis dot diagram, or they say diagrams, which is a hint. Well, we've got hydrogen carbonate, a hydrogen attached to a carbonate polyatomic ion. They give us some sort of help on this Lewis dot diagram. 3 carbon to oxygen bonds. They say 2 of the bonds have the same length. Okay. And a third is a little bit longer than the other 2. The hydrogen atom is bonded to one of the oxygen atoms. Draw the Lewis dot diagram. Okay, this one was worth 2 points. You'd expect it to because it's got some complications. Let me start by taking this carbon and putting that in the center of our diagram. And now 3 carbon to oxygen bonds. So I'm going to 1, 2, and arbitrarily this third one I'll just put underneath. The bond lengths I'm going to deal with a little bit later. I'm not going to worry about that on the Lewis dot diagram. I'm going to explain that later. But they do tell us the hydrogen atom is bonded to one of the oxygens, and that's pretty typical. But we've got the structure that's described. Thorough reading has done that. Let's bond these atoms together, putting just some little lines in there. I've got my second pair of electrons and a third pair of electrons, and then our fourth pair of electrons. And now all these atoms are now attracted to one another because those 2 negative charges that those nuclei are being attracted to. This said, do a Lewis electron dot diagram, so we've got to show the electron. And I've got my electrons here, but how many we're going to use? Well, that's where we're going to have to do a little bit of accounting and adding and see if we can add this stuff up together. Well, by now you know carbon has 4 electrons. You've done that often enough. Oxygen, we use, how many times we've done oxygen? 6 valence electrons. There's 3 of them. So that gives us 18 valence electrons. And then finally our beginning element, the first element of them all, which only has 1 valence electron. Now, if you're doing some adding as we're going along, you say, hey, odd number of electrons. Something's wrong. That's because this is a negative charge. They've put in an extra electron for us to even up. So we've got pairs of electrons all set. Let's see, 2 plus 18 is 20, plus 4 is 24. So we got 24 valence electrons to distribute. We're going to have to take care of 24 electrons. Now, we've already put some electrons in. We have 1, 2, 3, 4 pairs of electrons. 8 electrons out of these 24. So 8 minus 24 gives us 16 valence electrons to distribute. So we're going to have to put in 16 more by completing the octets of these surrounding atoms, except of course for hydrogen. That's easy enough to do. 6, that leaves us 10 more that are left behind because we've just completed this oxygen's octet. 6, so we've used up 12 electrons out of these 16. We've got 4 more left, and indeed, I'll put those on our oxygen here, and that oxygen will have its octet completed. So let me double check that I put out 16 electrons. 6 plus 6 is 12, plus another 4 is 16. Those are all of our valence electrons. Now, there's a problem here because our carbon doesn't have its required octet. It's going to have another pair of electrons from somewhere, and we've got some choices. This oxygen already has a couple of bonds. It's not rich in electrons. These 2 guys are rich on electrons, and we can drag over a pair of electrons, and we've got ourselves our carbon now with its 2, 4, 6, 8 is octet. We've completed our arrangement. You could have left those electrons there. Now, we had a choice of using this oxygen or this oxygen. When that happens, these 2 are identical. There'd be no difference whatsoever. I could have just as easily taken this and put it right down there, drawn a valid Lewis dot structure, because you could have done it in both places. We found out this pair of electrons actually is undecided too, and that it actually averages itself between these 2 positions. This one here is a bit different. The formula charge would be worse if we had a double bond here. You'll find out that things for the oxygen are not good. It's going to have a +1 formal charge. Anyway, it's so different, and as I explained, there are electrons at a better spot. And then we have a hint here. We have a hint. It says that one of the bonds is longer than the others. So here we have a single bond. Here we have a double bond. That brings the 2 atoms closer together, but this double bond is averaged between these 2 atoms. And as a result, these 2 bonds will be the same length, shorter than the sigma, and that explains everything. Now, you're going to have to show that in this diagram. There's a couple of ways. You could draw both of these to show the resonance, or you could use the dashed line. And this time, when you make the second drawing, that you have the right number of electrons. Oh, and that's right. That's one of the things to double check. We have 6 here, octet, octet, octet here. I'll have to get that extra pair of electrons and put it on this atom. And now everything looks good. Our hydrogen, of course, doesn't need an octet. Our carbons in both of our drawings do. You draw this, 2 solid points. You've taken, there's our Lewis dot diagrams, double bond which resonates, and our longer sigma single bond for that oxygen.